Hi, Integrated 2. Today we're going to talk about 8.1 Angles of Polygons. This is on page 475. I think you'll enjoy this one a little bit better than the proofs. Anyway, this tends to be a little easier for you guys, and it'll be more algebra also. So polygon interior angle sum. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. So as you can see, they've got multiple examples there of what a diagonal is. It just basically goes from one corner to opposite corners, and just make sure that you don't go to the corners that are right next to the vertice that you're going through. And so they've got triangle, quad, pent, and a hexagon. And so they're going to try to get to the n-2 times 180 formula, which I think we did go over last year, and we probably had it even the year before. So triangles, the interior angles of a triangle are 180 degrees. It's got three sides, and that's one triangle in a triangle, and so that makes 180 there. Now quadrilaterals, if you look here, quadrilaterals split into two triangles. So 2 times 180 degrees is 360. Pentagons have three triangles there. So 3 times 180 is 540. And so every time we gain a side, we gain 180 degrees. So every side gained, add 180. But instead of thinking that way, there's a formula that's been found that's n-2 times 180, where n is the number of sides. So that's the number of sides. And the -2 is because if you notice, every single time we have a certain number of sides, we have 2 less triangles than that. So like when we had 5 for a pentagon, we had 3 triangles in it. When you have a hexagon that has 6 sides, you have 4 triangles that you can make in it. It's right there. And so that's what's going on there. So n-2, and you're going to subtract triangles here because of the number of triangles. And you're going to take 180 because that's what triangles equal, or 180. And so you can use this to find the interior angles right here. Okay, so that's one of them you're going to want to stress and maybe underline interior. So it's inside. So if you want to find the angles inside any polygon, and so they also have convex here. I'm going to go over that in a second. So the inside angles of a convex polygon, you can use the number of sides, subtract 2 times 180. So they've got that written there. Now let's just go over convex and concave real quick. Convex, concave. The difference between a convex and a concave shape. A convex shape has all angles inside. They have to be less than 180. Concave, you can have a chunk of it like caved in, like that. And so this formula doesn't work for the concave ones because you've got this angle inside here that is way over 180 degrees. So convex interior angles are always less than 180. Okay, the more sides you get, the closer it gets to 180, but it'll never get there. So that's kind of the difference there. And so these only work for the convex type. Okay, go ahead and jump to the next page. Page 476. So if you'll read through this right here, you do need to have this down in your notes. And we have added 2 new ones, hendecagon and dodecagon. So before this, you were expected to know up to 10 decagon. So now we've just added 2 more. After that, you can use the n-gon. So please get this written down. They will throw these words at you often. Okay, they're not gonna say an 8-sided shape for you. You're gonna have to know what an octagon is, that type of thing. All right, so basically with this section, the only tricky part is keeping the directions straight with other ones. So if they ask you to find the sum of the measures of the interior angles of a convex heptagon, that is straight using the n-2 formula. They've got it right there, okay? And then they go, and you don't actually have to draw one with a protractor, but that's where they're going with that. Now, if they ask you to find the measure of each interior angle of a quadrilateral ABCD, first thing you're going to have to find out is what do quadrilaterals equal. That you can use the n-2 times 180. They do that right here. Okay, so quadrilaterals equal 360. Then you're going to add what you know. You know that x plus 3x plus 90 and 90 has to equal 360, and then you're going to solve the equation, and x is 45. but they want each interior angle. So you're going to have to take that 45 and plug it back into each one of those to find that. So x obviously is 45. The other two are 90 degrees. And then 3 times 45 is 135. So you would need those 4 angle numbers. So that one's kind of a 3-step problem, but it's mostly algebra, so I think you'll be okay with it. All right, so find the sum of the measures of the interior angles of a convex octagon. So the first thing you would have to do is do the n minus 2 times 180, where n is 8 minus 2, because that's what an octagon is. And then you're going to get 1080. And then you're going to need to write an equation and add up. Oh, sorry, I guess they don't. That's part of B. Never mind. That's all they want is 180. I'm doing 1B into 1A. So that's all they want is 180. 1080. So find the measure of each interior, this one. Find the measure of each interior angle of a pentagon. So this is the one where you need to find out what pentagons are. So step 1, 5 minus 2 times 180. Okay, so that's 540. Okay, then you're going to set up an equation, step 2, where you're going to say 2x plus 142 plus 2x, and you can add some of these together as you go around the way. I'm just not, because I'm showing you. 3x plus 14 plus another 3x plus 14 equals 540. You're going to go through and you're going to solve that, and go ahead and solve that and check it. And then once you find the x, you'll plug them back in to find every single measure. Okay, so that is what is expected of you in those kind of problems. Okay, and you can check yourself there on 1B. Okay, jump to the next page. Let's see. I'm sure you can kind of read that one. Let's look at 2A down here. Find the measure of each interior angle of the regular hendecagon. Remember, that's got 11 sides. So we'll hit edit here. This is 11-sided. So find the measure of each interior angle, each one of them, and it's regular, so that means that all of them are the same. So this is like the perfect 11-sided shape, and we just want one measure. So if we want all measures, we take 11 minus 2 times 180, and that would get me all of them together, but if I just want one, I want to divide that by 11. Let's see if we get what they've got there. So, all right, so 9 times 180, and I'm going to divide that by 11. And there it is, 147, and they've got the 3/11ths there, so we're good. Okay, the next one, a certain company makes hot tubs in a variety of different shapes. Find the measure of each interior angle of the nonagon model. Each interior angle, it's a regular, so it's a nonagon, 9-sided. So we've got 9 minus 2 times 180, and I'm going to divide that by 9 to find out. I think they wanted one angle there. So 7 times 180, and then I'm going to divide that by 9. 140. Yep, that's what they got. So every angle in that 9-sided tub is 140 degrees. Okay, jump to the next page. Page 478. Okay, the measure of an interior angle of a regular polygon is 135. Find the number of sides in the polygon. Okay, this is a little backwards. So we know that some polygon has 135 degrees. That's not all of the degrees. That's an interior angle. It didn't say angles, so you have to watch that plural versus non-plural thing. So I know that if I wanted to find out how many total angles I would have, I could take 135 times the number of sides. That would get me the total. But I also know the total is n minus 2 times 180. And so you can set this equation up and solve it through. And so they do that for you over there, and then the polygon ends up having 8 sides. If you took 8 minus 2 times 180 and then divided that by 8 again, you'll get one angle in that octagon to get 135 degrees. Let's do number 3 and see how that works out. The measure of an interior angle of a regular polygon is 144. So one angle in this polygon is 144, but the polygon has n amount of sides, and that's what I'm trying to find. So remember, this is the total inside angles, and so is this, the n minus 2 formula times 180. That'll get me the total too. As long as I have both n's, I'll be good. So if I take 144n equals 180n minus 360, I'll combine like 180, subtract 180n, and that's negative 36n equals negative 360, and so there my n equals 10. So this is a 10-sided shape, and so it's a decagon. Find the number of sides, it's a decagon. All right, now that was all interior angle stuff. That was all interior. Now they say exterior. So, and it is also a convex polygon. So it says examine the polygons below in which exterior angles have been measured. All right, so we know that 100, 140, and 120, they actually measured those. They got 360. Those are exterior angles. Same thing here, 40, 105, 110, and 105, measured to 360. That was a quadrilateral. This one's a pentagon, 65. All of these added up to 360. And so you can keep doing that, but for every shape, every convex shape, the exterior angles measure 360. Okay, so it's right here. The exterior angles sum. Okay, so all of them outside equal 360. Inside, it's a different story. But outside, they're always 360 as long as it's a convex. Okay, so let's jump to the next page and see what they've got there. Okay, so on this one, find the value of x in the diagram. Use the polygon exterior angle sum theorem to write an equation, then solve it. Okay, so we just said all of these things on the exterior. That's a pentagon, so there should be 5 exterior angles. It's going to equal 360. So they basically just set up an equation, add the like terms, put everything together, got 18x, and so they've got x equaling 20, and that's all they wanted. Now, if they would have wanted the angles, then you would plug 20 back into all of those and actually give the angles, but they didn't there. If it's regular, it's really easy because regulars have all the same angles. So I can't draw a nonagon, but it would just be 9 ends, and then that would equal 360. So it's that easy to get a regular one. Okay, find the value of x in this diagram. Okay, so that's a quadrilateral, but it doesn't matter. So it's 139 plus 6x, 2x, and 9x. That's 17 x's. And so then since they're on the exterior, they're going to equal 360. That doesn't mean it's because it's a quadrilateral. Yes, inside would also be 360 for a quad, but not for anything else. Okay, so it's on the outside here. And so then you would solve it, and you would get x to be 13. Okay. Find the measure of each exterior angle of a regular dodecagon. Remember, a dodecagon is 12-sided. So what they did was, we know that 12n equals 360. And so all they did was divide by 12, which is 30. And that's only because it's keyword regular. This one's not regular, so I had to do a little more work. But if it's regular, you can just divide by the number of sides there. Okay, I have a couple more extra examples here that we'll look at that weren't in your book. So on number 1 there, it says find the sum of the measures of the interior angles of a convex nonagon. So a nonagon is 9. So this is just asking for all the measures inside a 9-sided shape. So that is n minus 2 times 180. That's all it is. And so that's where they're getting 1260. Okay, find the measure of each interior angle of a parallelogram. So, parallelograms, that's 4-sided. So 4 minus 2 times 180, which you already know is 360. 4-sided shapes equal 360. So you're going to just kind of set up an equation here. We've got 11x, 11x, 22. So 32 x's plus 8, I added the 2 4s, equals 360. Subtract the 8. 32x equals, let's see, 352. Hopefully I did it all right. We're going to check it with a calculator because I need a calculator for the next one anyway. All right, so 352 divided by 32. There it is. It's 11. X equals 11. But what they wanted was the measures of each interior angle. So guess what? You get to plug them back in. So those two are 55, And if you plugged it back in there, you would get 125. Okay, so just make sure that you follow the directions on that one. So just a couple more here. All right, find the value of x in the diagram. All right, if I look at that diagram, it's got lots of exterior angles. Well, guess what? I don't have to worry about the n minus 2 if we're dealing with exterior angles. I just need to worry about that they all equal 360. So let's see. We've got, I guess I better edit it here. So we've got 5x plus 5. I'm just going to write them this way this time. 5x, I'm just going around the horn here. 4x minus 6, 5x minus 5, 4x plus 3, 6x minus 12, 2x plus 3, and I already did 5x plus 5. So I'm going to check. I got 1, 2, 3, 4, 5, 6, 7. Okay, I've got them all. Okay, so I know that if I combine these like terms, I'm going to equal 360 degrees because I'm on the exterior side. All right, so we've got 5 and negative 5. Those go away. And I got 3 and 3, which is 6, and then negative 6. So that's nice. I got a minus 12 going on. And let's see. We've got 5 and 5 is 10. 4 and 6 is 10. There's 20, 22, 20, 31 x's. Okay. So I'll take 360 plus 12, which is 372. And so I'm going to take 372 divided by 31. X is 12. There it is. Okay. Now be aware, sometimes they may ask you what are the angle measures, but in this one they just wanted the value of x. Find the measure of each exterior angle of a regular decagon. That's a 10-sided shape. So basically, the shape has 360 on its exterior, and I have 10 sides to deal with, and they're all the same sides. So I just need to divide by 10 there, and then that's where they got the 36. Okay, so that, I believe, is it for that one. Like I said, just make sure that you know what the question's asking for. There's enough questions in here that you can find one that's similar.